Hello everyone, this is Bharat from TBK Career Point channel. So now we are going to discussing about the concept of building blocks of the convolutional neural networks. So in the previous video, just we discussed what is called convolutional neural networks, right? So the convolutional neural network, it is a one variant of the neural networks. It is especially used for image classification. So the building blocks of the convolutional neural networks are majorly three parts. Three layers are the building blocks. Three layers are the major layers. One is the convolution layer. So as we are observing in the diagram, and a pooling layer and fully connected layer. So these are the important layers. So convolution layer. So when the image is or the uh, image is supplied as an input, then it will go to the feature extraction. So the intention of this model is to identify the features of the image properly. So to detect the all features properly, so we'll apply some mechanisms. uh, so that image will go through these all layers, and the features will be extracted, and then it will be supplied to the fully connected layers as we already discussed. So let us focus in detail about what is called convolution layer. The primary role of the convolution layer is feature detection, as we have discussed. So by applying various filters, these layers can identify various features within the image, such as edges, corners, or textures, which are crucial for understanding the image's content. If we see in this diagram, so if the image is supplied here, so that image size may be 28 by 28, as we already discussed, 56 by 56 pixels. So this image can be of a 2D type, 2D image or 3D image. So if it is of 2D image, convolution 2D, or it is of three dimension, it will be of 3D case, three type of color RGB colors will be there. So that image will be supplied and will go through the convolution operation. The convolution operation will be done here. So when you are performing the convolution operation, in this case we are taking the different kinds of measures, or different kind of components are there in the convolution operation. So one is take in the filters. So filters, different filters we are going to take in the for a image. Then we can able to detect the features without losing the information. So for that we can also apply the stride, and we can also apply the padding. So without losing the information or any type of feature from the image. So that is only here. So edges and corners are also important to identify the image properly. So once the convolution is done, convolution layer part is done, then it will go to the image will go to the activation layers. The activations can be used, rectified linear unit can be used, or sigmoidal uh, activation function used. After that, the output will be forwarded to the pooling layer, as we are observing in the diagram. So this image size will be convoluted, and then it will be sent to the pooling layer. So now pooling layer, what is the purpose of pooling layer is, it is going to downsampling the image from which is coming from the convolution layer. So it is reducing the dimensionality of the image, and without uh, loss of the features. Then the computational effect on the machine is going to be reduced by using the pooling layer. So we have major types of pooling layers are two types are, one is max pooling layer and one more is average pooling layer. The max pooling layer, it is taking the maximum value from the cluster of the neurons. So feature map detection, after doing the feature map detection, so a cluster లో number of neurons ఉంటాయి, a number of neurons లో the maximum value will be taken, and average pooling is in the cluster, the it calculates the average of that neurons. So any one can be applied on the model, either max pooling or average pooling. So then that whatever the information or whatever the output is coming from this part, convolution and pooling layer, that will be sent to the second convolution layer, and it is acting as a hidden layers in the neural networks concept. So likewise we can take any number of layers to extract the features based on the input and based on the data set. So if you take the number of convolution layers and pooling layers, so that are the number of layers we are taking in our model. So the feature extraction can be done, and filtering of the detection of the image will be done properly, and it is a chance to detect the image uh, properly. So this is called the output layer. And one more, the fully connected layer. So the fully connected layer, it is the one more important layer. So in this fully connected layer, అంటే ఈ fully connected layer కి data వచ్చేటప్పటికి it should be fully connected layers. In the architecture of CNN, after the convolution and pooling layers have done their job of feature extraction and dimensionality reduction, the role of making sense of these extracted features falls to the fully connected layers. So దీన్ని dense layer అని కూడా అంటాం. Fully connected layers play a crucial role, especially in classification tasks, where the goal is to classify the input image into various categories based on the learned features. So fully connected layer కి వచ్చేటప్పటికి క్లాసిఫికేషన్ అనేది జరుగుతుంది మీకు ఇక్కడ. సో దిస్ పార్ట్ ఈస్ కాల్డ్ క్లాసిఫికేషన్ పార్ట్, అండ్ దిస్ పార్ట్ ఈస్ కాల్డ్ ఫీచర్ ఎక్స్ట్రాక్షన్ పార్ట్. సో ఈ ఫుల్లీ కనెక్టెడ్ లేయర్కి డేటా రావడానికి, సో బిఫోర్ ది ఎక్స్ట్రాక్టెడ్ ఫీచర్స్ కెన్ బి పాస్డ్ ఇన్ టు ఫుల్లీ కనెక్టెడ్ లేయర్స్, దే మస్ట్ బి ఫ్లాటెండ్ సిన్స్ ఫుల్లీ కనెక్టెడ్ లేయర్స్ accept one dimensional vector of data, whereas the output from the convolutional pooling layers multidimensional tensor. Flattening is simply the process of converting the multidimensional tensor into one-dimensional tensor. So as we already discussed that, so if it is the image is the 2D or the 3D type, so it will be converted after the feature extraction into one-dimensional vector or one-dimensional array. So this one-dimensional array will be passed to the classification task. So then the number of neurons will be converted into one-dimensional vector. So based on that one-dimensional the neurons, it will be passed, it will be the classification will be done. So the classification, after classification, so we need to apply the activation function. So here the activation functions we can take in the case of binary classification. So we have to take the sigmoidal function. In the case of multi-classification, we need to take the softmax function. So the number of neurons, finally the dense output neurons will be depends on the number of classes we are taking in the data set. So this is the general architecture and basic architecture and basic explanation of the convolutional neural networks and basic building blocks of the convolutional neural networks. However, the multidimensionality or the one dimensionality depends on the two. If we are taking the 2D, then convolution 2D function will be taken. In the case of convolution 3D, we can take the convolution 3D, con 3D. So however, this is the theoretical part, general idea about the basic convolutional neural network architecture. But when you are implementing this by taking an example, so we have complete the process of how to execute the convolutional neural networks by taking an example. We'll see in the coming videos. So we need to implement it on the by using the Python language in the Jupyter notebook. So there we need to take the integrate the tensor flow and keras. So the keras, it is consisting of the all libraries which are required to build the convolutional neural networks, and the tensor is the framework. It is also one framework. There we can able to build the machine learning models or the deep learning models. So these all layers, convolution layers and the pooling layers, and the model is also the related parameters are also we need to tune and we need to execute from the scratch. So when you are building the convolution neural network from the scratch, so we need to start from the data set uploading to the model, to the platform, and thereafter we need to perform the pre-processing, and after that we have a different type of techniques for every stage, at every stage. So after this, in this diagram, after convolution, so and pooling, so we can also have the concept of batch normalization, in which case we need to perform the batch normalization. After performing the batch normalization, so it is a one type of set. Convolution, pooling and batch normalization is a one set of layer, and the again how many number of convolution layers are using in your model is a different from model to model, and depends on the problem statement. So after that, so what type of uh, model you are taking, that depends. So after that, the fully connected layers, so how many dense layers or how many fully connected layers we are taking in the case of classification, that is also the matter. And in between the so after executing the model, sometimes it may leads towards the overfitting or underfitting, as we already discussed in the previous videos. So if we get the type of problem, what we have to do, so this all will come in the practical session. So when you are executing the model, so definitely you will encounter all these problems. So there we need to focus on the different type of parameters, like so what type of simulation parameters we need to take, like weights and bias, and what are the hyperparameters we need to take in the case of tuning, like at the output layer, what is the process of complete building the convolution model. So that is uh, and what is the batch size we are taking, and how many number of epochs we have to run, and in the case of what is the loss function we have to take, and what is the optimizer we need to take. So these all are the very important things. And after that, how to evaluate the model, what are the measures are there, and how to predict the image, and how to generate the confusion matrix, and how to save the model. So these all are the important points in the case of model building and model construction, right? So that's all about today's video. We'll see in the more on this concept in the coming videos. Thank you all.